In this video, we'll use double factorial and factorial in the Taylor series expansion of cosine. We begin with the dataset of cosine, which is array formula, cosine of the x values 0 to 8. And we'll chart this. Insert chart, and we will use scatter chart. Use row 1 as header, column A as label. And the series, you show the trend line. The type, polynomial. The degree, try the highest. No, it doesn't work. Go lower. So 8 degree. And the label, use the equation. The legend, position at the bottom. So here's the trend line and the trend line polynomial of cosine. Next, we generate the Taylor series expansion of cosine. So we begin with the formula, the summation of a times x to the power 2n. A comes in two forms, the factorial, which is negative 1 to the power n over 2n factorial, and the double factorial, negative 1 to the power n over double factorial 2n minus 1 times 2 to the power n times factorial n. And the value of n is 0 to infinity, so we can use up to 16. Still good enough. Now we calculate the double factorial coefficient. So our formula, minus 1 to the power n all over. There are three parts. The first part, so double factorial. Double factorial 2 times n. So we copy the value of n here. This is our n, copy. So that is 2 times n. It should be here. 2 times n minus 1. So that's a double factorial. The second part, 2 to the power n, 2 raised to the power n. And finally, the third part. The third part is factorial n. So factorial of n. And enter. And we'll correct this error. So if n equals 0, this should be 1. So we'll correct this. So if n equals 0, if n equals 0, then it should be 1. Otherwise, calculate. Then enter. Now it's corrected. Next, we calculate the factorial coefficient. So this is equal to our formula, minus 1 raised to the power n divided by factorial. That is 2n. 2 times n. Then enter. Their values are exactly the same. Now we can calculate the expansion, which is our formula, series sum of the x values to the power 2n. X values raised to the power 2n. 2n starts from 0, then followed by 2, 4, 6, 8, so the interval is 2. And the coefficient, we can choose the double factorial or the factorial. We start with the double factorial. Then enter. So here we have the expansion, but no polynomial. So we show the polynomial. Edit chart, series, trend line, polynomial to the same degree 8. For the label, we show the equation. Now we're good. And the polynomials are exactly the same. We'll calculate these polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power is equal to transpose 0 to 8. That's our power. Now the elements of the matrix are the formula of the x values raised to the power 0 to 8. Then enter. Now we calculate the coefficients. So LINEST data y, that is for the function itself, comma, data x. Then enter. And the expansion. So LINEST data y and comma data x. Now let's compare. Coefficient of x to the 0, 1. Coefficient of x minus 0.0345. Coefficient of x squared minus 0.414. Coefficient of x cubed minus 0.0795. Coefficient of x to the fourth 0.0763. Coefficient of x to the fifth minus 6.44 times 10 to the minus 3. Coefficient of x to the sixth 1 minus 1.57 times 10 to the minus 3. Coefficient of x to the 7 2.72 times 10 to the minus 4. Coefficient of x to the 8 minus 1.16 times 10 to the minus 5. That's because I just used the factorial double factorial. Suppose I change that. I'm going to use the factorial. Let's see. So this will be our coefficient. You still get the same values. The polynomials are the same. All the lines are on the same trend line. And the data sets are the same. So we can use the factorial and the double factorial. This completes the use of double factorial and factorial to generate the Taylor-Maclaurin series sum expansion of cosine and its LINEST polynomial regression.